Hello and welcome to helpyourmath.com. In this video, we're going to look at adding and subtracting rational expressions with unlike denominators. And before we get to that, let's just review when we add fractions. What do we need if they don't have like denominators? So for example, if we wanted to add 1/2 plus 7/9, what do we need to be able to add these? We're looking for a common denominator. So what we want to do is we want to say, okay, what is the least common multiple, which we call the least common denominator, of 2 and 9, and that would be 18. So then I would say, okay, I need to multiply 2 by what to give me 18? I would multiply 2 by 9. And whatever I do to the denominator, I do to the numerator, right? Because I'm really just multiplying by a factor of 1. Then we do the same thing with 9. What would I need to multiply 9 by? I would need to multiply it by 2 to give me 18. We do the same thing to the numerator again because we're really just multiplying by 1. And then we would add the numerators and keep the denominator the same. So they would both have that denominator of 18. We would add across the top and we would get 23 over 18. That's what we're doing with rational expressions. They just look a little bit scarier than fractions. Here's my suggested steps for adding or subtracting rational expressions. We want to initially keep the numerators unfactored. So how they're written, leave them like that. Don't touch the numerators. However, factor each denominator. Determine the least common denominator by looking at the factors that are in the denominators to see what factors you would need in that least common denominator. Multiply any missing factors from each denominator as an equivalent of 1. Distribute in the numerator, but keep the denominators in factored form. So now we're going to distribute in the numerator, multiply whatever we need to do, keep the denominators factored. Then we add or subtract the numerators. Keep in mind that if it is subtraction, the entire second numerator is being subtracted, hence all the signs change. So if we have 1 over x plus 2 minus x minus 3 over x plus 2, when you go to subtract, you're subtracting this entire numerator. So this would become 1 minus x minus 3 over x plus 2. And then we would distribute this and we would end up with 1 minus x plus 3 over x plus 2. So just keep that in mind. It's a very, very common mistake to not change all of the subtraction of a numerator that comes after a subtraction sign, or to change all the signs. Okay, then we're going to combine the like terms in the numerator, see if the numerator can be factored, and if possible, simplify. Okay, let's look at some examples. Here we want to add, we have m over m minus 4 plus 2 over m plus 5. So currently as it stands, this fraction, this rational expression, has one factor in its denominator. M minus 4 cannot be factored, so that's the only factor. In our second rational expression, m plus 5 is the only factor in the denominator. So this indicates to me that our least common denominator is all of the factors of the first, which is just that 1, and the denominator of the second, the factor of the second. So that's going to be our least common denominator. That's going to be the smallest denominator that both of the current denominators go into. So we need to see, okay, what's missing from our first fraction in the denominator? We're missing the m plus 5. Whatever I do to the denominator, I also need to do to the numerator. So we're going to multiply by m plus 5 over m plus 5, because remember that really just means we're multiplying by 1. Then this would give me, let's see, I would have m times m plus 5, and my denominator will be m plus 5 times m minus 4. Now, what I sometimes see students do is now they cancel the m plus 5 factors. But remember, we just put those there to create the common denominator. So resist the temptation. I appreciate that you want to simplify, but we just unsimplified to create a common denominator. Now what we want to do is we want to take this denominator, it's missing the factor of m minus 4, and multiply by m minus 4. I'm going to also multiply the numerator, so that really what I'm doing is just multiplying by 1. This gives me 2 times m minus 4 over m plus 5 times m minus 4. So now what I want to do is rewrite this as one expression, and I can distribute or not in the numerator. I'm going to leave the denominators factored. Actually, I'm going to combine into 1. So I'm going to say m plus 5 over m minus 4. And now I have m times m plus 5 plus 2 times m minus 4. This is kind of an optional step, especially for addition. With subtraction, I would suggest taking that step so that you don't miss the subtraction sign, because again, it's such a common error. Here we get m squared plus 5m when I distribute, plus 2m minus 8 when I distribute the 2. All divided by m plus 5 times m minus 4. Cleaning up the numerator, I get m squared plus 7m minus 8 divided by m plus 5 times m minus 4. We want to see now if the numerator is factorable, and if it is, we want to see if it's going to simplify with the denominator. Target product is -8, target sum is 7, it is factorable. It would be m plus 8 times m minus 1. However, those two factors don't have any common factors with the denominator, so you could either leave your final answer like this or like this. I would just say, I would maybe leave this one, it doesn't matter. If your instructor wants you to multiply through, they might ask for that. I don't care, either one of these is fine with me. But that's what we do. Let's try it again. We want to subtract, okay. Here's what we're given, 2x plus 8 and over x squared plus 4x plus 3 minus x plus 4 over x squared plus 5x plus 6. First thing we want to do, factor the denominators. These are both factorable, so let's think about x squared plus 4x plus 3. That's going to factor into x plus 3 times x plus 1. Over here, x squared plus 5x plus 6 is going to factor into x plus 3 times x plus 2. So now we have 2 factors in the first denominator and 2 in the second. What's our least common denominator going to be? Well, we know it's going to require both of the factors from that first denominator, x plus 3 times x plus 1. We already have a factor of x plus 3 in our LCD, so I can skip that, but I do need a factor of x plus 2, right? Because that's a factor of the second denominator. So that should do it. I should be able to write both of these expressions with this denominator. What do I need to do to the first one? It's missing that factor of x plus 2. So I'm going to multiply by x plus 2 to the denominator, and I'm going to multiply by x plus 2 in the numerator. When I do that, that's going to give me x plus 2 times 2x plus 8 divided by, now I have all 3 of these in the denominator, x plus 3, x plus 1, and x plus 2. Over here I have the x plus 3, I have the x plus 2, I'm missing the x plus 1. So I'm going to multiply by x plus 1 over x plus 1 to this second rational expression, giving me, let's bring that minus down, I have x plus 4 times x plus 1, all divided by, and we have that common denominator of x plus 3, x plus 2, and x plus 1. Okay, so now that they have the same denominator, now we can write this as one single expression. And so this is going to be really hefty here. I'm going to write it all out first, x plus 2 times 2x plus 8 minus x plus 4 times x plus 1. So here's where we want to be super careful with that second term being subtracted. What you might want to do is go off to the side and simplify that and then bring it back following that subtraction sign. So just kind of like looking at this first. If I was to multiply x plus 2 times 2x plus 8, I would get 2x squared plus 8x plus 4x plus 16. So this would give me a grand total of 2x squared plus 12x plus 16. So this is that first one. How about the second one here? X times x is x squared, 1x, 4x, and 4. But remember, well, let's clean this up and then we'll talk. X squared plus 5x plus 4. Now, this whole thing comes after a subtraction sign. So all of the signs change. All the signs change following the subtraction. These signs don't change. The x squared, the 2x squared, we're going to just rewrite that. We have 2x squared plus 8x, 2x squared plus 12x plus 16 minus x squared minus 5x minus 4. Be very, very careful. Do you know why I'm saying this over and over again? It is the most common mistake I see when combining rational expressions. Okay, now in the numerator, we're going to combine like terms. I have 2x squared and minus x squared will give me x squared. So I'm going to get rid of those. 12x and minus 5x will give me 7x. And then I have plus 16 and minus 4 is positive 12. So x squared plus 7x plus 12. Okay, is that going to be factorable? Well, the target product is 12. The target sum is 7. Yes, it is. 3 and 4, right? That'll work. They multiply to 12. They add up to 7. And this was a lot of work, wasn't it? Do we have any common factors? Can we simplify this at all? Yes, we can. We have the common factor of x plus 3 in the numerator and denominator, leaving our final difference as x plus 4 divided by x plus 1 times x plus 2. I would leave it like this, and I would leave the denominator factored, but you should talk to your instructor in case they do want you to multiply through. I suggest not multiplying through because there's nothing worse than a student doing all this work, and this was a ton of work, and then somehow doing that little distribution at the end and making a mistake. It's so aggravating as an instructor. When I see that, it breaks my heart because then I have to take off a point because it's not totally correct and it's really sad. So I would say if your instructor allows, leave it factored. Okay, let's look at another example. This is an example that my students tend to freak out when they see. This is nothing to be afraid of. We don't have a fraction here. Eek! Turn it into a fraction by putting it over 1. Now the only factor of this denominator is 1, and the other denominator is 3x plus 1. So our least common denominator here is going to be 3x plus 1. So we're going to multiply by 3x plus 1 so that we have that in this denominator. Multiply by 3x plus 1. And this already has the denominator. So we have 2 times 3x plus 1 divided by 3x plus 1 minus 9 over 3x plus 1. We can go ahead and combine. This would be 2 times 3x plus 1 minus 9 over 3x plus 1. And now we can distribute. We get 6x plus 2 minus 9 over 3x plus 1. Let's combine our like terms in the numerator. 6x minus 7 over 3x plus 1. 6x minus 7 is not factorable. And that's it. There's no common factors between the numerator and denominator. Sometimes students get a little bit simplify happy and they're like, look, a 6 and a 3, that's exciting. Look, it turns into 2. No, it doesn't turn into 2. Because in order for us to be able to simplify that, the 6 would have to be a factor of the numerator, meaning it's present in all terms. And it's not. There's no 6 in the 7. So as tempting as that is, don't simplify it. This is the final answer. Don't simplify. It's not right. It's not even simplifying. It's just the wrong thing to do. Okay, one more example. We have x plus 4 over 2x plus 10 minus 5 over x squared minus 25. So I'm going to factor the denominators. This has a GCF of 2, so that's 2 times x plus 5. And here we get x plus 5 times x minus 5. Our least common denominator, so what factors do we need? Well, I know I need both the 2 and the x plus 5 from the first rational expression. And here I'm going to need an x minus 5. I already have the x plus 5. So this one's missing the x minus 5 factor, x minus 5, and this is missing a 2. Just need a factor of 2 here. Okay, so I'm going to go ahead and combine in 1. I'm just going to skip that first step. I'm going to go ahead and put this as just one single expression, and the numerator will be x minus 5 times x plus 4 minus 5 times 2. Now I'm ready to clean up the numerator. We're going to get x squared minus simplifying in my head, plus 4x minus 5x minus 20 minus 10 over 2 times x plus 5 times x minus 5. Okay, let's clean this up. So we have x squared minus x minus 30 divided by 2 times x plus 5 times x minus 5. Okay, now, can we simplify in the numerator? Not simplify, can we factor in the numerator? Yes, we can. Minus 30 would be minus 6 and positive 5, so this would factor into x minus 6 times x plus 5, all divided by 2 times x plus 5 times x minus 5. We have a common factor, and our final difference here is x minus 6 over 2 times x minus 5. I know these can be intimidating. I totally get that. Take your time with each step. I know you can do this. Thank you so much for stopping by.